Afternoon, we're going to be looking at Algebra I F15 perimeter area and volume changes due to changes in scale. So looking at this cube, it says the side lengths are doubled. So if I'm looking at that, that means that everything is going to go from 5 to being 10. And so to find the volume, which is what it's talking about, we're going to be multiplying 10 times 10 times 10. Now, if you notice, if I were to find the volume of the original figure, just that original cube that was there, I would have been multiplying 5 times 5 times 5. Well, because 5 times 5 times 5, each of those 5s gets multiplied by 2 to become the 10, then what we could think about is we could think of this 10 times 10 times 10 as 5 times 5 times 5, and I'm going to put my times signs in there like that, multiplied by 2 times 2 times 2. And what I'm really doing is I'm rearranging my two factors, 5 times 2, 5 times 2, 5 times 2, 5 times 2, etc. I'm rearranging them using that associative or using the commutative property of multiplication. And so if this is my old volume, we're just going to go ahead and make that V. Then my new volume is going to be whatever that 5 times 5 times 5 was, which happens to be 125. And we're going to multiply it by 2 times 2, which is 4, times 2 again, which is 8. So the new volume is going to be 8 times the original volume because the volume is measured in units cubed. So it was multiplied by my scale factor 3 times, once for each of those 3 units. 1, 2, 3 units right there. And so it's going to be 8 times the old volume. Okay, looking at this next one, it says the side lengths are doubled, and we're talking about perimeter. Well, perimeter is one-dimensional, so it's only going to be multiplied by the scale factor 1 time. And so if it's doubled, the new perimeter is going to be double the old perimeter, so it's going to be 2 times the old perimeter. I can prove it if I want to. So finding the original perimeter is going to be 6 times 4 because there are 4 sides on the square and all of them have a side length of 6, so that's 24. And my new perimeter, if all of these double, is going to be 12 on each side times 4 sides. That's going to be 48. And I can double check that it is going to be 2 times the old perimeter by multiplying my old perimeter by 2. And in fact, it is 2 times the old perimeter. Okay. Again, all of the dimensions are doubled, and we're talking about perimeter. Perimeter is a one-dimensional measurement, which means that it's measured in units to the first power. And so it doesn't matter what the perimeter is here, it's going to be multiplied. Since perimeter is multiplied or is measured in units, it's only going to multiply by the scale factor 1 time because units is measured in units to the first power. And so if it's doubled, my scale factor is 2, so the new perimeter is going to be 2 times the old perimeter. Now we're talking about area. Area is measured in units to the second power, or units squared, in this case centimeters squared, which means that it's 2-dimensional, which means that I'm going to take the old area and I'm going to multiply it by the scale factor twice. But there's a little bit of problem here. Only the height is tripled, not the entire, not both dimensions. And so if I were to draw a picture, this being the old rectangle 3 by 8, if only the height is tripled, then the new figure compared to the old figure is going to be 3 sets of this one. Now, this is going to be another 3, this is going to be another 3, so the entire side length is going to have a total measurement of 3 times 3, which is 9. This area of this whole rectangle, because again, only the height was tripled. If both of them were tripled, I could have just multiplied by 3 times 3, and it would have worked. But because only one dimension was multiplied by 3, then that rule doesn't apply. So 9 times 8 is 72, and those are 72 centimeters squared. And the old area was 8 by 3, which is 24 centimeters squared. And so I have to think to myself, what do I multiply by 24 to get 72? Well, I know it's not half. That doesn't make sense. 24 times 2 is 48. And I have a feeling it's going to be 3 times because this was tripled, but I'm going to double check it. 24 times 3 is in fact 72. And that works because algebraically, my old area was 8 times 3. My new area was 8 times 9. Well, if I expand that 9 and I don't write it as a 9, let me write it as where that 9 came from. That 9 came from the original 3 multiplied by the scale factor of 3. And you can see that if 8 times 3 was my old area, the new area was the same old area multiplied by 3. Anyway, I hope this video helps you to work on this skill. Again, you're basically looking at how many of the dimensions of the original figure are multiplied by the scale factor. And a lot of times, if they're all affected by the scale factor equally, like this one says all 3 dimensions, then you can just multiply by the scale factor the same number of times that the figure is measured in. For example, if it's perimeter, it's measured in units. If it's area, it's measured in units squared. If it's volume, it's measured in units cubed. So surface area is units squared, which means that whatever the old surface area is, it's going to be multiplied by the scale factor 2 times. So all 3 dimensions are tripled, which means I'm going to multiply by 3, not just once, but once for length, once for width, or base times height, however you multiply it. And 3 times 3 is 9. So the new surface area is going to be 9 times the old surface area. This one says the side lengths are tripled, meaning all of them are tripled. Volume is what it's looking for. Volume is measured in units cubed, which means that I'm not going to just multiply. I'm going to multiply it by 3 once for the length, once for the width, and once for the height. So my new volume is going to be 3 times 3 times 3 times greater than my old volume. 3 times 3 being 9, 9 times 2 being 27. So the new volume is going to be 27 times the old volume. All right, I hope this helps. If you have any more questions, give me a call.